Hi everyone, welcome back to MathSub's YouTube channel. In today's video, we will be talking about the various properties of integers and try to develop a basic understanding of integers and their operations. Let's get started. Great, so before we go into the properties of integers, let's refresh our understanding of the different types of numbers that we have in the universe of mathematics. So most of you must be remembering this, but let's just go through the basics. The first type of number that we all hear about is called the whole number, right? The whole number and the natural number. So what exactly is a whole number? The whole numbers are all positive numbers starting with a 0, right? 0, 1, 2 and so on. Those are all whole numbers. And now what is a natural number? Natural numbers are just whole numbers without the 0 added into the sequence, right? So starting from 1 to all the way up to infinity. Those are all natural numbers. And what are the third types of numbers that we talk about, which are integers? So integers are natural numbers plus the opposites or the negatives of natural numbers. So starting from minus infinity and then you go all the way up to minus 2, minus 1, 0 and 1, 2, 3 all the way up to infinity, right? These are all called integers. And now if you go further down the chain, you will find rational numbers. So how do you define a rational number? Any number which can be written of the form p by q, right? So if you can write a number in the form of p by q, where p and q are both integers and q is not equal to 0, that is called a rational number, right? And finally, you have your real numbers, right? So real numbers includes everything that is possible. Any number that you can imagine will be under the radar of real numbers, under the purview of real numbers, right? So any number like minus 1.2 or 2.736 or any other number that you can imagine are all real numbers. But there is another set of numbers which is even more complex, even though we don't really it's not going to be part of your GMAT syllabus. But just for your information purpose, we also have imaginary numbers, right? So the opposite of reals, which are usually made out of the number called the root of minus 1, right? So when you have the root of a negative number, which is usually not defined, we say it is a number called I, so it's an alphabet called I, and we create imaginary numbers based on this particular rule. And you can have 2i, 3i and all the operations that you do on real numbers. But anyway, let's not get into that right now, just for your information purpose. Now, once we have the basic understanding of all the types of numbers, let's look at some of the common operations that we tend to perform on these numbers. One of the most basic things that you will learn when you talk about integers is that we have something called a number line, right? So you will be able to represent all your numbers on a horizontal line. And if you start with 0 at the center, you have just one step to the right, two steps to the right, and so on. You can write all the numbers that you can imagine on this number line. And similarly, if you start going to the left, you'll have minus 1, minus 2, and so on. Right, so that's how you represent numbers on a number line, which is a very basic understanding. And the four basic operations that you perform on numbers are: first one is addition, second subtraction, multiplication, and division, right? So these are the basic things that we'll all learn. Just taking through a small refresher for this. So one rule which all of you need to know about when you perform any activity, any operation on an integer, is the famous rule called the PEMDAS rule. Or if you had studied in your school as BODMAS, it's exactly the same rule. So let's go over this rule, because if you don't really follow this rule, then you will end up making very simple mistakes on very simple questions as well. So what is this PEMDAS rule? The first P stands for parenthesis, E is for exponents, M is for multiplication, and D is for division, A for addition, and S for subtraction, right? So this rule helps you perform any operation in that particular order. So if you don't follow this rule, then you will end up with a different answer that is not what we mathematically follow. And this is more of a convention. It's not like if you don't follow this rule, you won't get an answer. But mathematically, since you have a lot of people performing similar kinds of operations, If you don't follow this rule, then your answer will be different from somebody else's answer. And that is the reason mathematicians have come up with a convention that we all follow, which helps us all of us stick to a particular standard of operations, right? So for example, if you take a question like 12 plus 3 minus 7 divided by 2 and multiplied by 8, and you have a parenthesis, let's say, which says 8 minus 3, and then you have a power rule of 5 power 2. Then in this case, if you start just from the left side, you will end up with the question answer like, let's say 12 plus 3 is 15, 15 minus 7 would give you 8, 8 by 2 is 4, and then you would say 4 times 8 minus 5 is 3, and times 5 square, so that will give you 20 times 25, right? So that's going to be 500. But that's going to be a wrong answer because you haven't followed the PEMDAS rule. So if you follow the PEMDAS rule, first you have to look for the parenthesis. If there's a parenthesis, you'll always solve the parenthesis first, right? So in this case, this is the parenthesis. So let's remove the old calculation. So the old answer was 500, right? Let's keep that. And let's solve this using PEMDAS rule. So if you have 8 minus 3 as the first operation, then you will say this is 5. And even though this is an exponent, the exponent is not part of the equation, it's rather a separate number over here, so that's okay. You can still say it's 25. And remaining rule, let's write it down. Minus 3 plus 12. Great, so what is the next step? So next step would be, we don't have an exponent part of it, so we'll take a multiplication. So it's either this or this. We can take either one, it's all the same. So if you say 5 2 is 10 times 25, that's 250, right? So that will be 12 plus 3 minus 7 divided by 250. So, right, so next step would be to solve the division, right? So next is D. So we have done with P, M and D. So since next is division, so we'll have to first solve for 7 divided by 250. So it will be 12 plus 3 minus 7 by 250. Okay, I'm just going to sort of take a approximation over here. So let's not go into exact numbers of 7 by 250. So I'm going to say, let's say is about 3.5 times, right? So it's about 1 by 3.5. And then let's say that's about, so it's 10 by 35, so that will be 2 by 7. So approximately 0.14, right? So that will be 12 plus 3 minus 0.14. Or probably it's slightly lower than that, right? So it's 0.014. 0.7 by 25, yeah, about 0.014. So let's say that's about 0.01. If it's 0.01, then next step for us is PEMDAS. Next step is addition, not subtraction, right? So we first need to go for addition, even though you have a subtract over here. So then you will have 12 plus 3 is 15 and minus 0.01. So that's about, you're going to get about 14.99. And that answer is way different from your 500, right? So that's exactly why you need to follow the PEMDAS rule. If you don't do it, you're going to get an answer. You will still be able to solve the operation, but you will not get the right answer that all of us are going to agree upon, right? So that's the first rule. Great. So now let's refresh our understanding on some more basic concepts of integers, specifically about even and odd integers. So we'll try to understand how different operations come together when we have even and odd integers, specifically addition, subtraction, multiplication and division, and how they interact when we have different forms of even and odd integers, right? So first of all, what is an even integer? An even integer is something which is divisible or is a multiple of the number 2, correct? So any number which ends with 2, 4, 6, 8 or 0, any integer which ends with these 5 numbers are all considered to be even numbers, and everything else like which ends with 1, 3, 5, 7 and 9 are all considered to be odd integers, right? Great. So now what happens? Okay, before that, is 0 an even integer or an odd integer? It is considered to be an even integer because it is sort of a multiple of 2, right? So 0 times 2 is going to give you a 0. So it is considered to be an even integer. Right. So now let's look at what happens when you add an even and odd integers together. If you add an even and even number, what do you get? You get an even number or an odd number? And any question like this, whenever a GMAT or any exam gives you, it's always better to use an example for you to check it if you're not sure about the answer. So if you have an even, let's say you have two even integers like which ends with a 2 or a 4, which you get 6, right? So let's say if you take a 6 and a 8, it'll end with 4. So it's always going to give you an even integer. So adding two even numbers always gives you an even number. That's the first one. And what happens when you add an even number and an odd number? Again, take an example. Let's say you take a 4 and a 3, you get a 7, right? So if you take a 5 and a 6, you get a 1, ending with a 1, right? So adding even and an odd number will give you an odd number. And if you add an odd and even number, of course, it's going to be the same as adding an even and an odd number, which is going to give you an odd number again. But what about adding an odd number with an odd number? What do you get then? So again, take an example. Let's say you take a 3 and a 1, you get a 4, correct? And you take a 5 or a 7. 5 plus 7 is 12, right? So it ends with a 2. So whenever you add two odd numbers, you're always going to be ending up with an even number, correct? Great. So what happens when you subtract two even numbers or subtract an odd number from an even number? Let's look at examples again. So if you have a number ending with a 2 and you subtract it from a number ending with a 4, it's going to end with a number 8, right? So it could be negative or positive, but it will always end with a number 8. So that's even. So if you have a number ending with a 6 and you subtract with a number ending with a 0, it's going to be an even number again, 6. So subtracting two even numbers will always give you an even number. Or what about subtracting an even number from odd number from an even number? So let's say you take an odd number like 5 and you have an even number 2. So 12 minus 5 is going to be 7. It could be negative or positive, but it's always going to be ending with a 7, correct? So even number minus odd number will always give you an odd number. Now what about odd minus even? Again, very similar to the previous case. It's going to be an odd number again. So if you take an example like let's say 7 minus 4, it's going to be 3, right? So it's going to be odd. And what about subtracting two odd numbers? Again, very similar to our addition case. If you subtract 3 and 1, you're going to get a 2. If you subtract the 7 and a 5, you're going to get a 2 again. So subtracting two odd numbers will always give you an even number. Great. Now what about multiplication? If you have an even number and multiplied by an even number, it's kind of easy to see what it's going to be, because what's the definition of an even number, right? So even number is always going to be a number which is multiplied or divisible by 2, correct? So if you have two even numbers, that means you have two 2's in that equation. So there's no possibility that it cannot be even, right? So it will always be an even number. In fact, any multiplication, even if you have one even number in the entire multiplication, the entire number is going to be even, because even 1, 2 is enough for you to make the entire number even, correct? So anything multiplied by even is always even. So even and an odd is going to be even. Odd into even is going to be even. The only case where you get an odd number in a multiplication is when you have everything to be odd. So you have two odd numbers, then you can say it's an odd number. That's the only possibility. So you get an even here and you get an odd in one case. Great. So what happens when you divide an even number with an even number or even number with an odd number? Now, in the first case, dividing an even number with an even number depends on the scenario. If it's possible that it could be odd or it could be even. Now let's see how that's possible. So an even number, when you have in the numerator, then you have an even number at the denominator, correct? So in this case, it's possible that there is only 1 2 as a factor over here, or it could be 2 2's as well, or it could be 3 2's as well, correct? In the denominator, you could have only 1 2 or even 2 2's. But if you have all 3 2's that could be cancelled out in the numerator and denominator, then you could end up with an odd number in this case as well. Let's say in this case, an even number like 2 times 2 times, let's say a 3, which is 12. And you divide that by a 4, which is 2 times 2, right? So if you divide a 12 by a 4, both are even, but you will end up with an odd number. So that's one case. But what about if you divide 12 by only a 2, which is 12 by 2, both are even, but you will still end up with a 6, which is an even number. So depending on the scenario, the answer will change. So you can't really say what an even by even will give you. But even by odd will always give you an even number. Why? Because in the numerator, when you have even and you have an odd at the denominator, you know that there's going to be at least a 2 in the numerator, correct? So since it's an even number. But if there's an odd number in the denominator, you can be sure that there will not be a 2 because there's no possibility of getting cancelled. So you'll always end up with an even number here. Great. Now, in the case of an odd divided by an even, you'll again end up with most likely always going to be an odd number because there is no 2 in the numerator for you to be ending up with an even number, correct? So you'll always end up with an odd number. And finally, if you divide an odd number with an odd number, it's obviously going to be an odd number, correct? Because there is no 2 in the entire scenario that we're talking about to end up with an even number. Great, so that's all for today's video. Thank you for joining us today. If you like the video, please do hit the like button and share it with your friends so that they can also be part of our learning journey here. And do subscribe to our channel to be informed of further updates about GMAT Focus Edition that we'll be sharing. Thanks.